friends, in the last lecture we just discussed about the difference between process and a program. Program is just a code, and when that program is alive or in the execution, it becomes a process. Okay, now the next step is we are going to learn threads. Okay, so let's see what are the threads. Okay, so a thread is a basic unit of CPU utilization. It consists of a program counter, register, and a stack space. So basically, a thread we use to exploit the CPU cycles. So we are going to use a practical demonstration at the end of this video. So you can say the thread is execution under a process. So there may be multiple threads running continuously under a certain process. You can take an example of Microsoft Word. When you are typing, it automatically display the grammatical underline, that is in a green line, a red line, and when you're typing, it also counting the number of characters, number of words in that particular file, and all that thing is run under only one process. Okay? But there are several threads executing under a same process. So process is treated as a heavyweight process, whereas thread, it is a lightweight process. So the benefit of a thread versus a process, that would be clear from this diagram. You can see on the left side there is a single threaded process, or you can say a simple process without any threads. There is only one single line of execution. And whereas on the right side you can see my process is having a 3 threads. It means I can use the CPU cycle via 3 line of execution. So in this, the code, data, and files are common to all the threads that belongs to a simple one process, whereas each thread has its stack and register. So now, what's the benefit is that the less time to create a new thread, because to create a new process, I need all these code, data, and files separately. But to create a thread, I need only register and a stack. Okay, so the next point is less time to terminate a thread than a process. The same concept would be implemented on the second point. And the third point is less time to switch between the two threads within the same process, partially because the newly created thread uses the current process address space. Less communication overhead. Communication between the threads of one process is simply because of the thread shared everything. So these are the benefits of the thread. And the multi-threaded, many threads can run under a single process. So benefits are responsive, resource sharing, economy, scalability. Okay, so now user level threads. So user level thread, you can use the POSIX portable operating system interface, pthreads. It's an open library. We are going to use this pthreads to demonstrate how to deal with the threads. And the second is Win32 threads for the Windows and Java threads. And the second is the kernel level threads. So it's implemented by the operating system. Okay, we are going to learn only user level threads. Okay, let's go to the tab C. So in a dev C, I'm going to create a new file. Okay, so I'm going to use a pthread library. pthread.h, and the second header file would be standard input output.h. This would be my main function. So now I'm going to make use of pthread library, pthread underscore t, to create a 2 threads. Let's suppose t1 and t2 are my 2 threads. Pthread underscore create. So this is a function to create the threads. So it will contain 2 arguments. The first, 4 arguments. The first is the reference to the thread. Second one, I am putting a null, that is to customize the memory space if you are going to give. And third is a routine it's going to call. So let's create function 1, and the last is if you want to pass some argument to the function or a routine. So I'm going to copy this and I'm going to create the same thing for t2. Let's suppose this is my function 2. So after this I'm going to use thread underscore join t1 comma null. So it's mandatory to join the threads. It's going to wait t2 comma null. It's going to wait until the process is going to terminate. Okay, so now I'm going to create the functions. It should be void star is going to return a null pointer. One is the function name with no argument. Okay, here let's declare a global variable int x equals to 0. Okay, so let's suppose function 1 is incrementing our x, and here I'm going to print okay, let's suppose the value of x. Okay, so I'm going to create the same function, similar function, that would be function 2, and let's suppose this time I'm going to decrement the values, and here let's specify something that output from fun1, and here /n, so that it would be in new line. Okay, the same for the function 2. Okay, so let's write it. It's asking to save the program. I'm going to say thread underscore .c. Now you can see the same program. This is the same program, and this is the output. The first output is from the thread 1 and second is from the thread 2. Okay, this is all about programming, basic programming of the threads. We will continue with the more about the threads in the next lecture. Thanks for watching.